Hello, I'm Gopinath Chakravarti, Assistant Professor, Department of Mechanical Engineering. Today I am going to demonstrate Introduction to Finite Element Analysis. Well, what is finite element analysis? Finite element analysis or finite element method is a numerical method technique for finding approximate solutions to problems of engineering and mathematical physics. It basically solves boundary value for problems of partial differential equations. In simple terms, FEM is a method for dividing up a very complicated problem. Suppose the problem has a very complicated geometry. For simple geometries, we can use analytical methods taught in strength of materials. But for a geometry like as shown in this figure, we cannot solve it just by mere analytical method. Now, how does the FEM works? FEM uses a complex system of points called nodes, which makes a grid mesh. Now, in this individual grid mesh, we could see this body being subjected to some sort of force or a load, and due to that, only this portion is getting distorted, and due to that, there is a distortion, and we could see a temperature gradient which is varying from blue to red. Now, if we see it minutely, we could see that there are small triangles in which this entire domain is broken down. So, what exactly finite element does? In this figure, we could see this object is broken into three triangular elements, and the junction of these elements are called nodes. In these node points, we could find the displacement, and correspondingly from the displacement value we could find out the stress and the strain values. Now, types of engineering analysis. What are the different aspects or the sectors where we could apply finite element method? We can use firstly in structural analysis. Structural analysis contains, it can be done for both linear and non-linear models, and mainly in linear models the material is plastically deformed, not plastically deformed, it is elastic deformation, and in non-linear it is beyond the elastic deformations. We could see this cantilever beam, and we could see here the force is varying from blue to red, where red is the maximum force or the maximum load. We could see gradually the color varies as we move towards the junction point of the cantilever beam. Now, secondly, vibrational analysis. It is basically used to test the material under random vibrations, shock or impact. Now, the bridges are usually constantly being now the bridges faces continuously some random vibrations, and sometimes this vibration can match the natural frequency of the material, bridge material, and due to which resonance may occur and a catastrophic failure may occur. Fatigue analysis. Fatigue analysis, it is mainly used to predict the life cycle of a material subjected to cyclic loading. And now we can also apply this to thermal analysis also, where we will find the heat gradient of this system. Now, mainly broadly, FEM simulation can be broken into three phases: pre-processing, solution and post-processing. Pre-processing is the initial part where the problem statement is formulated and all the force functions or the force vector field or the force matrix, elemental force matrix is developed. In the solution phase, the governing matrix are solved, and in post processing, the visualization of the results are calculated in the solver. How FEM is useful in product development? It reduces redesign cost and therefore it shortens the product development time. It identifies the issues or the errors or the problems rightly in the design phase only, even before the real prototyping is formulated. FEM is highly useful for certain constrained areas where, suppose if we have to simulate a crashing of a car or crashing of an airplane, it is not physically viable to make a physical form of that uh, aeroplane and then do failure analysis. Here FEM simulation is very much useful. It optimization the overall product performance before prototyping. Thank you.